In lab number 8, we're introduced to integrated ISIS routing. We begin by discussing some of the characteristics of ISIS. We'll see how it's going to play into our specific topology and take a look at the addressing. ISIS uses NSAP addressing, and we'll break that down for you. We'll take a look at the syntax for setting it up. Then we'll go out to our routers and we will configure them for basic ISIS operation. Then we'll play with a couple of features. Specifically, we're going to configure area authentication and domain authentication. Finally, we'll verify that operation.
The intermediate system to intermediate system, or the ISIS protocol, it's part of the OSI protocol suite. You might remember OSI, or the Open Systems Interconnection model, from your early studies of networking. One of the protocols defined by OSI is Connectionless Network Services, or CLNS. This can give us connectionless delivery of data. However, the Layer 3 protocol that does the delivery of the data unreliably is CLNP, Connectionless Network Protocol. And when we talk about ISIS, ISIS by its nature routes CLNP traffic. However, we are primarily interested in routing IP traffic. But by default, ISIS does not support the routing of IP traffic. However, integrated ISIS does route IP traffic, and that's going to be our focus here in this lab. We're going to take a look at integrated ISIS. And as we consider some of the characteristics of integrated ISIS, realize that it's very similar to OSPF in some respects. It's a link state protocol. It uses the Dijkstra algorithm. We can break our network into different areas similar to OSPF, but a very important concept that we need to understand is that integrated ISIS defines two different levels of routing. We have level 1 and level 2. Level 1 routers can use link state packets, or LSPs, to construct a topology for an ISIS area. However, between areas, we need to have some level 2 communication going on. A level 2 router can construct a topology between ISIS areas. But what about a router that might be sitting on the boundary? It's connecting to other routers within an area, but it's also the router that connects this area to another area. It needs to do some level 1 functions in addition to some level 2 functions. That type of router is called a level 1, level 2, or a level 1 -2 router. And by the way, when we're setting up our integrated ISIS configuration, that is the default router type, a level 1, level 2 router. Let's review the topology that we're going to be working with. When we think about these ISIS areas, it differs somewhat from the way that we think about an OSPF area. With an OSPF area, oftentimes we think of interfaces as belonging to specific OSPF areas, and we might have one interface in one area and another interface in another area. With ISIS, instead of thinking of links belonging to an area, we think of the router itself, or the system belonging to an area. So in this lab, R1 is a member of Area 100. BB1, BB2, they are members of Area 100, and router R2, it is a member of Area 200. You'll also notice that R1 and R2, they are level 1, level 2 routers. They could talk within their area using LSPs to construct an area topology, and they can also talk to a different area using level 2 to construct this topology between areas. And this is going to be our first step in this lab. We're going to go in and configure ISIS on all of our routers. Then we want to take it a step further. We want to add some authentication. We want to add neighbor authentication between the routers in Area 100, between R1, BB1, and BB2. One way of doing that, we can go into the interfaces, or in this case the sub-interfaces that interconnect these routers, and we can set up some neighbor authentication. We can give the interfaces an ISIS password, and this password is going to need to match in the routers at both ends of these links in order for them to form an ISIS adjacency between them. Also, to make sure that we don't have any rogue routers joining Area 100, we're also going to set up area authentication. We're going to make sure that all of the routers that belong to Area 100 have a common area password, and we will also want to set up domain authentication to authenticate different areas. Specifically, we will go into routers R1 and R2, and we will configure those routers, those level 1, level 2 routers, with a domain password, and those will have to match to be able to share information between these different ISIS areas. And when we're dealing with integrated ISIS, we need to understand some special ISIS addressing. Let's consider that next. When we're setting up integrated ISIS, we're going to have to go into router configuration mode and configure an INSAP address for each of our routers. INSAP, that stands for Network Service Access Point. We need to set up an ISIS INSAP address. And the structure for an INSAP address is defined in the standard ISO 10589. However, there's some flexibility built into that standard. There are some different ways that we can construct an INSAP address. I want to show you a very simple way of doing it. The first portion of the INSAP address is called the Authority and Format Identifier, or AFI for short. And if we're dealing with a locally administered network, the AFI is typically set to a 49. So we're going to begin our INSAP address with a 49. The next 4 digits can then represent the area. We have 2 areas, area 100, area 200. We could represent area 100 as, for example, 0100. Next, we will want to give 12 digits to identify the system. These 12 digits could be the 12 hexadecimal digits making up the MAC address of one of the router's interfaces. However, I prefer to use an approach where we use an IP address from the router's loopback interface. For example, router R1 has a loopback IP address of 1.1.1.1. What if we represented the number in each of those octets as 3 digits? We would have 12 digits, would we not? We would have 001, 001, 001, 001. And that's one way of constructing the system ID. And what I like to do is to type in all 12 digits first, and then go back and insert the dots, the periods, after every 4th digit. For me, that's easier than trying to figure out where to place the dots and keep the number of zeros straight as I'm typing in the system ID. We'll illustrate that for you in the lab. And then finally, we have the INSAP selector, or the IN selector, or the IN cell as it's called. And the IN selector is going to be a 00 for a router. So in each of our examples, the IN selector is going to be 00. If we put all this together for router R1, we're going to have an INSAP address of 49.00.0100.0100.1001.00. Next, let's take a look at the syntax that we're going to be using. First, to start the ISIS routing process for IP on the router, we're going to say router ISIS. This takes us into router configuration mode. Here we say net, and we give that INSAP address, as we just discussed. And remember that routers can be of different ISIS types. By default, a router is a level 1, level 2, or a level 1-2 router. And that's going to be the case for router R1 and R2 in our example. However, BB1 and BB2, they're only going to be level 1 routers. So for those 2 routers in router configuration mode, we will want to say IS-type space level-1. And between our level 1, level 2 routers, R1 and R2, we will want to, in router configuration mode, give a domain password that's going to need to match between these 2 routers, acting as level 2 routers to one another. And within the area 100 containing R1, BB1, and BB2, each of those routers in router configuration mode will be configured with an area password that needs to match for each of those routers. But what about the interfaces? For the interfaces, we go into interface configuration mode, and we say that an interface is going to participate in the ISIS routing process by saying IP router ISIS. And to set up the neighbor authentication with the other side of an ISIS link to make sure that we don't have an unwanted adjacency form, we could give the ISIS password command, followed by the password. And in our example, we're going to say level-1, because when R1 is talking to BB1, or BB1 is talking to BB2, or BB2 is talking to R1, these routers are going to be speaking to one another as level 1 routers. So we will say ISIS password, give a password, and say level-1 for each of the interfaces interconnecting the routers within Area 100. That's the theory and the syntax. Let's now go out and see how to set up integrated ISIS. Let's begin our configuration on router R1. On router R1, we go into global configuration mode, and let's begin the ISIS routing process by saying router ISIS.